Hi, I'm Ms. Vung. Let's have a look at probability tables. Here we have a Venn diagram. We know that that's the intersect of A and B. We have looked at last time that that is A intersect not B, so A but not B, and that's the opposite, not A intersect B. So how would we write this? Oh, and there's not A and not B on the outside. How would we write this in a table? Well, in a table, it's the intersections that go in the middle. So A intersect B is there, and then A intersect not B is there, not A intersect B is there, and not A and not B is there. So A intersect B is there, A not B is there, not A and B is there, not A not B is there. This is called a Carnot map, and then we'll see that the probability of these two add up to the probability of A. So when we go across, it adds up to probability of not A. When we go down, these two add up to probability of B and probability of not B. And the beauty of this is when we add the last row or the column, it should give us the same value, which is 1, because A and its complement will give us 1 and B and its complement will give us 1. This is called Carnot map. So it's very handy because we can write probabilities in there. Let's have a look at what it looks like. So A intersect B looks like that. Let's see if visually A not B, if these two add up to what we wanted, which is A. Well, let's fill in these two first. So not A but B will be there, and not A and not B will be there. So now we can see that if we go across, adding this one and this one would give us A. And going across, B not A and not A and not B does give us not A. See, not A. And when we go down, the intersect of A and B, adding to the intersect of B but not A, does give us just B, as we expected. And then likewise, this plus this gives us the complement of B, or not B. And the beauty of this is when you can see when you go across, that adds up to the whole thing, and also when you go down over there, it adds up to the whole thing. So how do we use this? Let's look at an example. If A and B are advanced such that probability of not A is 0.25, probability of not A intersect B is 0.12, and probability of B is 0.52, we're going to answer some questions, but first let's do the Carnot map. So not A is 0.25, that goes here, not A. Oops, that was really fast. Let me do it again. So not A goes here. The A intersect, sorry, not A intersect B, so not A intersect B, that goes there. And then probability of B goes down here. But we know that when we go across and we go down, it adds up. So we can see that that should add up to 1. We'll check that later. But we can see that this section here, because it's supposed to add up to 1, then that must be 1 minus that, which is 0.75. And we can see that these two have to add up to 0.52. So that must be 0.52 take away 0.12, which is 0.4. Now we can go across. We can see that this has to add up to 0.25. So 0.25 minus 0.12 is 0.13. Now going across there, we can see 0.75 minus 0.4 is 0.35. And adding these two should give us the same as doing 1 minus that. And it does, 0.48. So your last digit, doesn't matter where you go, the last digit you double check on both horizontal and vertical so you know you're correct. What do we do with all these numbers now? So we can answer the question. What's the probability of A? Well, it's over there, 0.75. A complement of B, so that goes there, 0.48. A intersect B, it's over there, 0.4. And A union B. So if we have A and we have B, then A union B is A and B, take away the intersect. So A plus B, 0.75 plus 0.52 minus the intersect 0.4, which is 0.87. Just a quick recap of what the cards are: red and black suits, heart, diamonds, clubs, and spades, the 4 aces, the number cards, the picture cards, and we have 52 cards in total, 26 red, 26 black, 13 in each suit. These are called suits, these 4 things, and 4 of each number, so 4 aces, 4 twos, 4 threes, etc., and 36 number cards, so this pink box here, and 12 picture cards. I'm just quickly recapping because we've done this before already, but we're going to use it. So let's use that to answer a question. Suppose a card is selected at random from an ordinary deck of 52 playing cards. Let A be the event of a picture card, and that is Jack, Queen, King, and C be the event that it's going to be a heart. So let's list the outcomes corresponding to A and C. So remember, A is a picture, so any of these, and C is all the hearts. So there are 13 hearts altogether. So let's put a symbol there so I don't get confused. So A is picture cards. There are 12 picture cards, you can see here, whereas there are 13 hearts in total. Now we can figure out that the probability should add up to 1, so that space there, the complement of A, or the complement of not obtaining a picture card, is 40 of 52, and the complement of not obtaining a heart is all the other shapes, that is 39 over 52. Now the intersect of the heart and a picture card, there's 3 of them there, and that is going to help us fill in the gap. So 13 minus 3 is 10. Oh, sorry, we're going over here. 12 minus 3 is 9, so 9 goes there. 13 minus 3 is 10, so 10 goes there. And we're going to double check. 39 minus 9 is 30. When we go across, does 10 plus 30 equals 40? Yes, it does. So we have obtained all the right values. Let's find the probability of A. That's 12 over 52, or 3 over 13. Probability of C is 13 over 52, or 1/4. Probability of A intersects C is right here, 3 over 52. Probability of A union C, again it's A, 12 over 52, plus C, 13 over 52, minus the intersect. So 12 plus 13 minus the intersect, which is 22 over 52. Sorry about the skip. So A union C dash would be A plus C dash minus A intersect C dash. So that's A and complement of A. I'm not sure where I put it there. I'll have a think of it. So we have A, and then C dash is here, 39, minus the intersect 9 over 52. So we obtain 42 over 52, which simplifies to be 21 over 26. And don't forget to always simplify your answers, otherwise you lose half a mark leaving it as an unsimplified fraction. So you can see how useful the kernel map is. And remember, going across, it adds up to the last value. Going down, it adds up as well. Thanks for watching. I'll see you next time. Bye.